Hi students, this is Mr. Yao. Today we are going to talk about 6.3a, where we will learn about angles that's generated by secants, tangents, and chords. First, prior knowledge. We have already learned something about angles already. It's inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc or central angle. So, inscribed angle would mean an angle like this, right here. That's an inscribed angle. When an angle is generated by two chords, and the chords actually meet at one point on the circle. And that angle is half of the arc it's intercepting, or is half of this central angle. So ADB, the measurement ADB is half of the measure of arc AB. That's what we have learned before. Now, based on that, we can draw some conclusions. An inscribed angle is a right angle if and only if it intercepts a semicircle. So you can see this is the inscribed angle, but because this is diameter, that means whatever is on this side is actually a semicircle, which is 180 degrees, which makes this inscribed angle 90 degrees. And that's the only situation you can actually get a right angle for the inscribed angle. It has to intercept with a semicircle or diameter in this case. We also can draw some conclusion called same arc theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. As you can see, this angle right here is intercepting with arc AB, and this angle right here is also intercepting with the arc AB. Since they're both going to be half of AB, that's why these two angles are just going to be the same. That's called same arc theorem. Now let's use these and look at some examples. Example 1. What is true about all the numbered angles in the illustration? You can pause here to think through. The idea is every single one of these angles being numbered, they're all facing this arc right here. So they're all going to be half of this arc. That is why they are all going to be the same. That's example 1. Example 2, find arc SD. First, we may notice that because this is a inscribed angle and it's facing this arc DQ, there's also this angle that's facing arc DQ. So we would know that is actually going to be 34 degrees. And if that's 34 degree, well, I take it back. We actually don't need that. We would know this arc in that case is going to be 68 degrees because it's twice of the inscribed angle. Next, we may notice is this arc right here is actually intercepting with a diameter, which makes the whole thing 180 degrees. That's why we can just use 180 degrees minus 68 degrees. That is going to give us 112 degrees, which is the question mark. That's example 2. Example 3. The measure of angle LVX. In this case, you can see is the question mark. Now, if we already know this is 74 degrees, and right here is a diameter, so a lot of time diameter, that piece of information you're not going to be given. That's why you need to know, you need to look for that diameter so that you can have some 180 degrees that you can use. Because that's 180 degree and this part is 74, that means the leftover is going to be 106 degrees. And question mark or angle LVX is facing this arc. That means it's going to be a half of 106 degrees, which is 53 degrees. That's example 3. Example 4, find the question mark. This one is slightly different because if you just look at this as facing this arc, we kind of, well, it's actually still kind of the same, I guess. There's two different ways to look at this. First, 56 is facing this arc right here. That means this arc is going to be 112 degrees. And then we have a diameter again. That means the leftover is going to be 180 minus 112, which is 68 degrees. Since the question mark is facing that arc is going to be half of 68 degrees, which is 34 degrees. That's one way to look at it. Here's another way to look at this question. If that is 56 degrees, this would also be 56 degrees because they're facing the same arc right here. And this angle right here is facing the diameter that makes this 90 degrees, so you can also do 90 degree minus 56 degrees, because that means these two angles together is going to be 90, so I use that total 90 minus the 56. That's also going to give you an answer as 34 degrees for the question mark. Moving on, do a bit more. 10x plus 8 is labeling that angle. 12x minus 2 is labeling that angle. They are both facing the arc YZ. That means they're the same. 10x plus 8 equals to 12x minus 2. Subtract both sides by 10x. I have 2x. Add both sides by a 2. It's going to be a 10. So x equals to 5. But we're not done. The question is actually asking you for the measure of arc YZ, which is going to be twice of the inscribed angle, which is 10x plus 8. So 10x is 58 plus 8 is 58 times 2. That is 116 degrees. That is the measure of arc YZ. That's example 5. Moving on, example 6. Angle 1 is given, arc BC is given, and it's asking you to find x. This is 2x minus 4. This currently is being labeled as 3x plus 11. However, because this inscribed angle is actually facing that arc, that means the arc is twice of the angle, so that arc could also be represented as 4x minus 8. All I did was multiply everything by 2 in that inscribed angle. So that means 4x minus 8 is actually the same as 3x plus 11. I just need to subtract both sides by a 3x and add both sides by an 8. That gives us x equals 19. That is example 6. Moving on, now we have more theorems. Tangent and chord theorem. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So for example, this is the tangent line, and we're having two angles, 1 and 2. The theorem is basically saying if this angle is 1, it's going to be half of the arc being intercepted by this angle, by these two lines. So it's basically saying angle 1 is half of arc BA, or AB, right here. Angle 2 is on the other side, and that is going to be half of the other side of the arc, which is arc BCA. So these are kind of easy to understand, but this is slightly different. It's not quite shown on the graph. So since we already know with this arc BA, if we connect BC and CA, this is the inscribed angle. The inscribed angle is going to be the same as half of the arc. And half of the arc is also the same as this angle outside, which is angle 1. So that is why angle 1 is also the same as angle BCA. These are the same. That's another theorem. Now let's use it in some examples. Example 5. The measure of angle 1 is 100, it's asking for that. The arc is being intercepted is 130, so that means this would have to be half of that, which is 65 degrees. Next, arc KJL. KJL. Well, the angle is right here, 125 degrees. All I need to do is multiply by 2. That is going to be 250 degrees. Example 7. The measure of arc RT, right here. That means if I want to use the tangent angle, I would need the angle on this side. But because this is a straight line, I know the other side is 98 degrees. That makes this side a 92 degrees. And if that's the case, RT is going to be twice. Well, not 92, it's actually 82. RT is going to be twice of this angle because that's the arc being intercepted. So that means the measure of RT would have to be twice, which is 164 degrees. And that is example 7. Next, example 8. Now things are going to get a bit complicated, but my suggestion, right after each piece of information or each sentence, make sure you stop putting those things inside your classroom. So, angle 1. Make sure you actually label everything inside the circle, like angle by angle. Angle 1 is 40 degrees. Great. Now I would know this arc AC is going to be 80 degrees because it's going to be twice of this angle. I would also know, because this arc is 80, I would also know angle 4 is going to be half of that, which is 40 degrees. Next, arc BC is given as 130 degrees. This is 130 degrees, which means the half of that is going to be right here, which is 65 degrees. Now, let's see what else we still need to find. This is a straight line. We already know this is 40 degree and that is 65 degree. So we just need to use 180 minus 40 minus 65. And that is going to give us minus 105, 75 degrees. And that is angle 2. As for angle 5, it is actually facing the arc BC. So that's going to be half of it, which is 65 degrees. Now let's put everything into their question. Arc AC is 80 degree. Angle 2 is 75 degrees. Angle 3 is 65 degrees. And angle 4 is going to be 40 degrees. Angle 5 is 65 degrees. And the measure of of arc ABC is going to be 300 minus the one side, which is 40. And that is going to, well, arc ABC. Minus 80. And that is going to give us 280 degrees of arc. That is example 8. And that is everything for 6.3a. Thank you.